My name is Radek Vokal. I'm one of the organizers here, and I'm glad that we have a full house here. And not only in this room, but as I've heard in every other room that we have in this building. So it's going to be a great event. So I'm going to do a very quick introduction about this conference, very quick group housekeeping stuff, so you guys know what to expect here. So first thing, this is DevConf a couple of years ago. I was actually looking yesterday, how long are we doing DevConf for? So this is the 9th conference that we're organizing. But since we skipped 1 year, this is 10th year of organizing DevConf. So it's sort of an anniversary to this this time. So thanks a lot. And DevConf is getting bigger and greater. So first thing first, for people who has been here already a couple of times, you guys probably know about this, but for those who are here for the first time, DevConf is organized for developers and by developers. It's a volunteering conference that is not organized in a professional way. We have a lot of volunteers helping us out. So what I want to ask you for is be open-minded and help out where you can. So most of the speakers, or all of them, are not professional speakers. Some of them speak here for the first time in front of such a huge audience. So be patient, open-minded, and respect that they are a little nervous, that they will be probably a little nervous, and again, they'll be presenting this for the first time. So what do we have for you? So there'll be 3 keynotes. One keynote will be starting right after I'm done here. These keynotes are a little different. We didn't want to do an ordinary keynote, so these will be more of like a joint session of several engineers, several developers, telling you some interesting stories. So I hope you will like that. And on top of that, we have more than 200 sessions. It was very hard this year to pick these 200 sessions because we had over 500 submissions. So you can imagine that it was a lot of work to come down to a schedule that we've created for you. We intentionally picked some new topics and new speakers. So you won't see the same old, you will see some new people, and hopefully you will like it. It's going to be probably a little different than last year. Or that's the intention, for sure. It's going to be different than last year. One thing, and you can probably see it already here, the rooms are getting full quite quickly, so please do respect the full sign. We have restrictions here on the capacity of these rooms, so if the room is full, try to find some other, or in the worst case, it's always streamed. Yeah, hopefully people can hear me in the other rooms again. So respect the full sign, please. Food options. So in the lobby here, there's a huge sign or whiteboard with all the food options. The food trucks are sort of hidden over there, so there are a couple food options for you ready. And if you ask anyone from the volunteers, there's a couple good restaurants around here where you can always find something really good. Now let's go through 10 things to do when there's no Wi-Fi. Seriously, so Wi-Fi is working here in every room. It's actually right there, written in red. There's information how to log into a university Wi-Fi, but there are some restrictions. The restrictions are no torrents, no porn. If you start downloading something like that, you will cut off everyone else in this room. So be careful about it. And don't do any mobile hotspots as well. It messes up the local Wi-Fi setup, so just don't. You've probably heard about the party tonight, right? Not tonight, sorry, tomorrow night. So the party is unfortunately limited, so there's only 700 places available at the party. At the registration desk, you can still get a button that will let you in, that will be the entrance ticket to the party. I would actually encourage you, if you can't get to the party, look around you, grab some people and do your own. There's going to be a couple more events for sure happening during that night. And I guess there's still registration going on for a sightseeing tour tonight. So if you want to get a little bit excited about the town here, you have never been here before, and you're not afraid of damn cold that we have outside today, you can sign up for that sightseeing tour, and it starts right after the last session. Of course, there's a Twitter hashtag, DevConf.cz, or there's a Telegram room. There are links on the whiteboards in front of this room and other rooms. If you need anything, if you want to talk to the organizers, if you want to help with something, follow this. Also, any changes to the schedule, if we drop some sessions or move some sessions, will be announced on both Twitter and Telegram. And also, if you look at YouTube, DevConf.cz is our official channel, and hopefully most of the sessions will be streamed almost online, right? Almost. So, one important thing, I've already mentioned that this conference is organized by a large group of volunteers. So all the people who have these nice black t-shirts with the volunteer sign-on are here to help you, advise you some, if you need any advice, to give that to you. I would like to thank especially to the University of Technology here, because without their great help, we wouldn't have this nice venue. Please, make sure that we leave this venue as we get it. So make sure that you don't leave any trash behind, you don't break anything. You're very careful about this again, nice venue that we got from the university. And as you might have realized from the schedule, DevConf is becoming kind of a shelter conference for other conferences. So the folks from OpenShift, the folks for JBoss are pretty much organizing their mini conference during this event. So I would like to thank them as well, because they've been a huge help for helping us organizing this whole thing. And then last thing, moje.fedora.cz, our official Fedora portal. All the sessions and probably a couple of interesting articles will appear there after DevConf. So follow that, look up there for any sessions that you will miss here, and yeah, let's go read that. So with that, thanks a lot, and I'm going to hand it over to my friend, boss, and our VP of Engineering, Tim Berg.
Thank you, Radek. Doby Den Bruno, welcome. How many people here saw the keynote I gave 2 years ago? We talked about DevOps, hybrid cloud. A lot of people? So I'm not given the same thing, and in fact, they told me I could only talk 10 minutes, so I don't know what we learned from that. But, okay, so what we're going to do is, the main purpose of this talk is I'm going to refresh a little bit of the material we talked about 2 years ago, but then the real question is this stuff real, right? 2 years ago, I laid out this vision of this beautiful environment where you can dynamically provision hardware, and that the DevOps world where the software developers can seamlessly deploy on that infrastructure. And it's a great story, but the whole point here is to see if it's real. And so to do that, I've invited a lot of the crew here from Brno, and they're going to have a series of segments where we're going to talk about these different things. Oh, I guess I need the clicker. Okay, Mark Andreessen has a quote, "Software is eating the world," because it really is. You know, all the stuff that used to be in hardware is now in software, whether it's cars or telco, network gear, or mobile phones, or everything. And what a great time for us to be developers, right? There's so much cool stuff going on. There's never been a more interesting time. And let's look at a couple examples of that. One such example is Volvo Cars, automotive company. Because now cars don't just drive you somewhere, right? Look at the software in them. It does navigation, it does entertainment, it does diagnostics, it does connection to cell and other things. And there's a lot of trends in autonomous cars and electric hybrid vehicles. So all this stuff, it's really getting software down into the low-level hardware. And so what this means is that companies that used to just like typically their IT departments were like overhead. You'd run your accounting software or your mail services and stuff like that. But now what software is doing, it's really adding value to the vehicles or whatever product they're introducing. And it's not just automotive. This is a few examples we have. One such example is Paddy Power Betfair. They're from the UK. They're an online gambling site. And they do millions of transactions a second. And their software tie-in is that they want to be able to dynamically scale out and provision based on when there's World Cup events or other, to be able to burst up and down. Another example is Target department stores. And so they've done a huge effort to have a DevOps environment in order to have a consistent experience between the online shopping as well as how they operate in their stores. And the last one we show is Amadeus is a travel service, and what they have been doing is they are constantly trying to get new apps rapidly deployed to be able to add new services really quickly. So it's a very wide diversity of industries. But the challenges for DevOps is we have the developers who want the latest and greatest bleeding edge stuff. They just want to grab things and they just want to ship it. And to the other side, on the operations side, that's chaos, right? Because how do we control, where did this stuff come from? How do I know there's not viruses in it? How do I know it's up to date? How do I know it works with certain things? And so the real challenge of DevOps is to find a world that can satisfy the needs of both developers and operations. And so what we're going to do a series of demos through this session. It's to talk about how we are using operations to deploy our environment, and then we're going to show how developers can develop their applications seamlessly onto that environment. So it's a really good way of meeting the needs of both developers and operations. But in order to do that, you can't just do the same old stuff that you've always been doing. In the past, a lot of the applications were monolithic, just one big blob of an application. But that doesn't work anymore. And so that's where these new tools come in to meet the needs of developers and operations, to be able to have agile processes and to be able to have low-level cloud infrastructure that allows dynamic provisioning. And even on the application front, where applications were typically just one piece, now they're breaking up into what's called microservices. And that's the ability to decompose applications into discrete pieces so that you can update them independently. So you don't have to deliver and deploy one whole huge application every time you want to add a little piece to it. And it's not just multiple pieces, but it's how do we coordinate that across clusters of systems? Because it's not just, you don't have everything running on one box. You want to be able to run across multiple machines and even across multiple clouds, and that's what we call hybrid cloud. And you need orchestration services to pull that all together. And so these are the things that we're going to be talking about in the demonstrations that are coming up. But it's also important to have a flexible infrastructure, because people want to be able to build and deploy these applications on bare metal hardware, on virtual machines, on-premise cloud, meaning cloud that's running on hardware right within your data center, but also on public cloud. And you want a set of tools that enable you to use the same development tool and to be able to deploy on those multiple environments, because that's where a lot of the errors would come in the past. If you had to build your application differently for every environment, then it makes it difficult to test it, and really difficult. It requires a lot of knowledge for each of those. But what we're going to show is how we can abstract all these different deployment models and make it really easy to deploy anywhere. So here's the outline of the demos that we're going to do today. We're going to go from bottom to top. We're going to start with the hardware side. And our first demo is going to talk about how we discover the hardware and how we provision it as part of our environment. So basically, we're pulling in the hardware resources into the pool. The next demo is going to take these bases of hardware, the pool of hardware, and we're going to create virtual machines on it. And that way we can have more scale on the systems, and we can better share the resource utilization. The next step we're going to do is create identities and accounts and policies Because when you have clusters of systems or large numbers of systems, you want to be able to migrate workloads to different places. You want to be able to have a common set of accounts. You don't want to have to create the same accounts everywhere. And so that's where identities become important in this cluster of systems. And then we're going to create a pool of dynamic virtual guests, because typically these environments, what you want is the developers to have self-service, meaning you don't want the developers to have to submit a ticket to the IT department and wait several days until a VM is created. What we want is self-service portals that enable people to dynamically spin up virtual machines. So we'll be demoing that as part of OpenStack platform. The next thing we're going to do is provision a containerized application. So this is where we transition from the ops side onto the dev side. So now that we've got all our resources, virtualized guests, containers created, we're going to use OpenShift to create a series of containers on top of that. Then what we're going to show is CloudForms. And CloudForms is a high-level system management tool that's going to enable us to monitor the resources in our environment. We can do things like see which systems are up to date, which ones have the right latest versions of the software. And we're going to be able to do like scale out and bursting through CloudForms. And the last part is we're going to talk about deploying applications with middleware services via JBoss EAP. And this is a really cool demo from the developer side because it really ties it all together. It shows that the developer is going to run and deploy their applications on the infrastructure that we created in the preceding steps. So it's really an end-to-end use case from ops to the developer world. Through the course of this keynote address, we're going to be referring to this architectural diagram. And each one of the sessions, as they do their piece, you will see through animation that it'll be grayed out for the parts that haven't been discussed yet. So what you're going to see as we go through this is the diagram is going to become increasingly populated and filled in. And if we've done this successfully, you should really be able to see the end-to-end flow. So you don't need to really follow the diagram right now because we're going to be getting into it in each of the upcoming segments. Okay, and then the last part, we're just going to talk about what did we see? Is this stuff real? Okay, so with that, we're going to turn this over to our first speaker. And that is Martin Pevic, right? Oh, I'm sorry. Didn't appear.
Yeah. Thanks, Tim. So, hello everyone. So the first demo is about the satellite. So I will play the nice animation by Nenad Peric that will show we just bought a couple of boxes that we want to give some meaning in life. And we'll use satellite for the first part where we will deploy satellite and using the quick start cloud installer that helps us to bootstrap this process a bit. We'll deploy the Red Hat virtualization so that we can actually start using VMs instead of bare metal that scales a bit better. And on top of Red Hat virtualization or RHEV, we'll deploy CloudForms that will help us managing the cloud infrastructure that we'll build later. So without further introduction, this is the satellite UI. We deployed this into our environment using the ISO image, and we let that discover the host or the hardware that we are going to provision. So you can see here that in the provision host, we have two boxes right now, one smaller one a bit bigger. We used Puppet Facts for knowing what actually is there. And we'll switch to the CloudForms quick start installer so that we can use this to install various Red Hat products such as Red Hat Virtualization, OpenStack, CloudForms, or OpenShift. So in this demo, we'll use we will install RHEV and CloudForms. On top of that, we'll give some name to this deployment, prefill some defaults as the default password that we're going to use. We are next asked how we want to treat the updates. This is the functionality of the satellite, where it can let you control which updates you actually want in your infrastructure or whatnot. So right now, let's give all the updates that are available to the systems. Then we are asked how we want to deploy the RHEV. We'll go for the engine plus hypervisor. This setup is better for like scaling up the infrastructure later. We'll choose the smaller instance for deploying the management console or the engine of RHEV, and we'll use the more beefy machine for the host, hypervisor host. This will be actually the machine running the VMs. So after that, we need to prefill some settings such as type of CPU or storage. Tomáš will talk about that later. In next step, we are asked where we want to deploy the CloudForms. If we used QCI for installing OpenStack, we could put it there, but right now we'll put it just on the RHEV. So after some other leaving some defaults there, we are given the overview of how the deployment will look like, and with the next button, the thing just starts happening. So what actually happens is the satellite is synchronizing the RPMs from the internet so that we have availability locally. Then foreman that is part of the satellite is configuring the DHCP, TFTP, DNS, all these records on your services that the unattended provisioning works. And we can actually start installing the basic OS. After that finishes, foreman hands over to the config management. In this case, it's Puppet that finishes the installation of RHEV, and then we'll put the CloudForms inside this RHEV. So while we are waiting for the deployment to finish, I would like to mention that Satellite consists of many upstream projects that make this really nice UI working at the end. So there is Foreman for provisioning and configuration management. There is Candlepin for subscription management, Pulp for handling content such as RPMs or Docker, and we integrate with OpenSCAP or we provide remote execution capabilities. And we have really nice coverage of these projects at this conference. So first of all, there is a booth in the hall with the Foreman. So we show a lot of features the Foreman or Satellite has. And there are several talks. There is workshop about the Foreman today afternoon. This is the introductory one, so if you haven't seen Foreman, I recommend going there. And we have talks about remote execution today. We have talks about Pulp and OS3. We have talks about Foreman and OpenStack tomorrow in the OpenStack room. And there is also Spacewalk workshop on Sunday that was based Satellite 5. So after the deployment finished, we see RHEV running on one machine and the CloudForms on other. And just to prove you that Satellite is not just this nice UI that can get you started with your deployment, you can use it in like day-to-day operations. And this is actually the reports that we got from the config management that show what actually happened to one of those hosts. So this is all my demo. We have now Satellite, RHEV running together with CloudForms, and I'll hand over to next speaker.
Thank you, Ivan Nechas. Well done. Okay, so we've discovered and provisioned our hardware. The next step, now that we have that, is we're going to create virtual machines on it. And for that, we have Thomas Jelinek going to describe it.
Thank you. This talk is RHEV hosting CloudForms. So from the previous talk, I already have an instance of RHEV running with one hypervisor configured and one instance of virtual machine hosting the CloudForms. In this talk, I will use an external satellite instance to deploy a new host and live migrate this CloudForms virtual machine on that one. And when I will leave, RHEV will still host the CloudForms and will have enough resources which will be utilized by the upcoming talks to deploy some more load on it. So this is RHEV. RHEV is a traditional virtualization solution which is organizing KVM hosts in the clusters and manages virtual machines on them. This is the dashboard which is showing you some nice overview of it. In the top left corner, you can see that there is one up and running host. So I will deploy a new one. I could use our internal stuff, but in this case, I will offload it to the satellite. All I will have to do is just to fill out the name of the hypervisor and its root password. And when I will submit this dialog, satellite will discover the host, install the operating system on it, install the repositories and all the packages needed to act as a RHEV hypervisor. Do all the configuration both on RHEV side and on the bare metal side. Until it is done, I will just quickly mention that RHEV is providing lots of different services for its virtual machines. For example, storages and networkings. For networkings, we have our internal networking, or you can offload it to the OpenStack's Neutron, very same way as I used with this satellite. Or for storage, we have various storages we support. For example, GlusterFS, NFS, iSCSI, Fiber Channel, or any POSIX compliant hardware storage. So in the bottom part, you can see how the operating system and all the packages are being installed. And for stages. Yes, so it's almost done. When it will be done, the host will join the cluster and will become operational and will be able to host some load. All this will happen in an unattended way. As you can see, I haven't clicked anywhere. So now it's green. So let's talk about the virtual machines. Virtual machines are the core of RHEV. RHEV is great if you want to manage large virtual machines which demand long uptimes. One virtual machine can have up to 288 virtual processors and 4 terabytes of RAM. If you need to do some maintenance on the underlying hypervisor, you can just take the virtual machine and live migrate it to another one with zero downtime. I am mentioning migrations because there was a large effort to enhance it, and I had the pleasure to be part of it, so I'm quite proud of them, and I'm showing them. Now also large and heavily loaded virtual machines are migrating blazing fast and reliably. So to conclude, RHEV is a major solution. It has been around for many years and will be around for many more. But this doesn't mean that the development is stale there. We keep exploring new options and experimenting on every single layer of our stack to make sure that we stay competitive and cutting edge. Thank you.
Thank you, Tomasz Jelinek. Next, we have Martin Kosek, who's going to come up, and he's going to describe how identities and policies are created cluster-wide.
Okay, thank you for the introduction. In the next part of our story, we will deploy an identity management service for the whole infrastructure, free APA, so that can serve the next parts of the infra. In my part, I will first, of course, introduce what identity management is, because it may not be well known to everyone, and then continue with demoing how we set up a server of IDM called free APA, and a client SSD on a Fedora Atomic host, which is a container-focused operating system deployed in a RHEV that you could see in a previous case. Free APA is a service for your infra that provides centralized storage for identities and their security credentials and security policies for these entities, and then based on this, it provides authentication and authorization service for the whole infra. What this means in practice, for example, identities, these are typically users and their passwords, and by policies it may be like how long these passwords before it's expire, or if this user needs to use some more advanced authentication like a two-factor or smart card, and and the whole goal of having this centrally is to provide like unified authentication and authorization experience to the users, so that you don't have to set this all manually or separately on these nodes and applications. As for some of the other advantages of using free APA, first, well, it's integrated with the other applications, so and part of the infra. And second, it can collaborate with the directory, so that you don't have this like unified experience just for Linux users, but also for Windows users, because they are part of the directory realm, and the AD realm can have a trust with IDM, and they can log in, for example, to the satellite or to the other parts of the infra. Okay, let's move to the actual demo. As I mentioned, we have set up a Fedora Atomic host on a RHEV from the previous case. So first we log in to the RHEV and we install a container containing the FreeIPA server. The installer of the container asks for some basic data about the FreeIPA, and when it gets the data, it will set up all the components of the FreeIPA solution. So this may be like the typical service you could expect from IDM, like a LDAP server or Kerberos server for authentication and so on. When the container is set up, it's available for all the infrastructure. We will demonstrate it just by showing that the web dashboard is available this is the web dashboard is available for the infra. Now, to actually demonstrate what that FreeIPA works in this part, is that we will set up a client on the Atomic host called SSD, which binds the actual operating system to the FreeIPA server. So as you could see, we simply installed an SSD container which joined this system to the FreeIPA server, and suddenly all these interfaces on this local host are bound to the FreeIPA server, and any user operation is resolved against FreeIPA. So now we can actually show how we use this infra by opening the FreeIPA web management console, where you'll first click around a bit so you can see what other services it can offer. For example, you can see that it can do certificates for the users or other policies, and we will add a user in this FreeIPA dashboard just by filling a couple data for the user, and when this data is there, this user can log in to any part of the infra where the user is allowed. In this case, it's the Atomic host. Of course, so as you can see, now we can SSH, enter password, and the user is allowed. And in the same case, it will work with all other parts of the system that are joined to this identity management. So before I conclude, let me just mention that there will be other presentations related to security or IDM, where you can join and learn more about what we do. Thank you.
Thank you, Martin Koschek. Okay, so we have our identities created. The next thing we're going to do is create a dynamic pool of virtual guests with OpenStack. And for that, we have Jirka Tomaszek.
Hey. Okay, so as a next step, we're going to deploy OpenStack, so we can later install OpenShift on it, and we'll manage it with CloudForms. We're using OpenStack Cloud because it gives us the ability to scale the environment as our requirements are growing. For OpenStack deployment, we're using quite an interesting concept of deploying OpenStack on OpenStack, which basically means that we are using OpenStack's own facilities to deploy it. For our deployment, we're going to be using 4 bare metal nodes, 1 node for the OSP director itself, which is driving the deployment, and 3 nodes for the OpenStack infrastructure itself, which consists of 1 controller and 2 compute nodes. As part of the OSP director, we get the brand new director UI, which I'm going to be using to drive the deployment. And so I'm going to log in using the credentials from IDM from the previous presentation. And once we log in, we're presented with a deployment plan page, which guides us nicely through the process of deployment. So as you can see, the first step is to prepare our hardware. So we're going to be doing deployment of 3 nodes. So I'm going to register those. And to to be able to deploy them, we need to first introspect them to get all the necessary hardware information. And then we'll just provide the nodes for the deployment saying that they are ready to be deployed. Once this is done, we can actually move on to configuring the deployment. The directory UI provides a list of predefined high-level features which we can enable. It's also pretty easy to add custom ones because it's driven by the heat templates. So in addition to the basic configuration, I'm doing the network configuration where I'm going to enable the network isolation, which takes care of creating several isolated networks, and I'm further specifying this with the single NIC with VLANs option. In addition to those, I'm also enabling my custom network environment, which holds the parameters specific to my setup. The OSP director introduces a concept of roles. Each role represents a node type, which runs a set of OpenStack services. So we have currently 3 nodes which are ready to be deployed. So I'm going to assign 1 node as a controller and 2 remaining nodes are going to be compute. Once this is done, we're almost ready to start the deployment. As you can see, we're getting the warning. As you may have noticed, we have a validation sidebar, which is this section provides a set of pre-deployment and post-deployment system checks, which provide instant feedback during the deployment design process. Each validation is an Ansible script, and we made it fairly easy to create custom ones. So we can add custom ones to support some specific user requirements. Once all of our pre-deployment validations are passing, we're safe to start the deployment. Once the deployment starts, we can track its progress, as well as see all the resources as they are being installed. And in the meantime, I'd like to invite you all to the OpenStack sessions, which we have here at the DevConf, so you can get more information about the topic. Also, the directory UI is a modern JavaScript application written in React.js using Redux architecture. And we're putting a lot of effort into gathering feedback from the end users, and so we make sure that this tool is actually usable. Once the deployment finishes, we're presented with the credentials, and we can start using our OpenStack. So now we're ready to start installing OpenShift. Thank you.
Thank you, Jirka Tomaszek. You know what's cool with this stuff is most of this, it's really guided GUI deployments. It used to be the case to install OpenStack, you had to be a rocket scientist. Maybe even I could install that. What do you think, Hugh? Maybe, absolutely. All right, there we go. All right, so next up we have Jan Provaznik, and he's going to talk about OpenShift for us.
So, in the next step, we will deploy OpenShift in the OpenStack environment, which was prepared by Jirka. We will take a closer look at the created resources, and finally, we will log in into the deploy OpenShift. For the deployment, we will use OpenShift on OpenStack project. It's a collection of heat templates, and these templates are then used by OpenStack orchestration engine to create infrastructure resources. And it also runs OpenShift Ansible playbooks, which set up the OpenShift cluster itself. For the demo purposes, we will create 8 VMs, 3 for running OpenShift master service, 2 for running OpenShift compute service. There is an infrastructure node for running registry and router. And the bastion node is for running OpenShift Ansible playbooks, and the load balancer balances requests between master nodes. Let's start with the demo. We start the deployment by running stack create command. and we pass it a custom configuration and also an LDAP file for using the IDM server, which was prepared by Martin. And we tell it to create three master nodes and 2 compute nodes. The OpenShift itself, the stack creation takes around 30 to 60 minutes. So maybe we can skip to the end of the creation. And at this point, we have a stack complete, which means that the OpenShift cluster is ready to use. And we can check the list of created Nova instances. And we can see that all of them are up and running. So now we will switch to the OpenStack UI, and we will take a closer look at the network topology. The color lines are defined networks. The blue one is public one, which is pre-existing. The orange one is infrastructure network, which is used by all nodes for talking to each other. And the green one is containers network, which is used by containers running in the OpenShift cluster, and only OpenShift master and compute nodes are connected to this one. In the next step, we can take a look at the details of a single instance, or a single master node instance. We can see that it has a set of firewall rules defined, and also a set of IP addresses for each of the network. And at the bottom of the page, we can see that it has also a Cinder volume attached to this one instance, and it's used for a Docker storage. And in the next step, we can look at the stack overview page. And this stack overview page is interesting because you find there all the information how to access to the OpenShift cluster. And there is also console URL, which points us to the OpenShift cluster. And now we can use the employee user to log in into the running OpenShift. So OpenShift on OpenStack is purely integration project. It doesn't contain much logic itself. Rather, it uses OpenStack and OpenShift tools. So if you are interested of any of OpenStack or OpenShift projects, you are lucky today because there are many talks, so you can choose. Thank you very much.
Thank you, Jan Pravaznik. Okay, so now we've got our OpenShift environment created, and now we're going to provision containerized applications within OpenShift. So now we're transitioning the boundary from the ops side, and this begins the dev side of the presentation. So next up we have Marek Olfart.
Thank you. Hello everyone, my name is Marek, and now when the OpenStack is deployed and runs, and there is also running CloudForms, we can go to day 2 management. CloudForms can control various type of cloud services, including OpenStack, OpenShift, Azure, VMware, and so on. What I'm going to show you is first the OpenStack both over cloud and under cloud as a cloud from the CloudForms point of view. Then we will set up a compliance to validate host CPU usage, and then we will perform scale down action on OpenStack under cloud. In order to do that, we first need to log into CloudForms. In the CloudForms, there is a dashboard with basic overview of the cloud and the most important charts and statistics, including resources usage. On the left side, there are categories of the providers, which is how CloudForms call service it manages. And there is also a bunch of powerful features about automate and control these things. In order to see OpenStack under cloud, we need open infrastructure providers, and there is RHEV and also the OpenStack, which we are going to focus on. There are basic information about capacity and resources about OpenStack, including a relationship to OpenStack services. To be able to see under cloud in graphical representation, there is a cool feature which is topology view, which shows us the most important inventory there, which is provider, compute deployment role, and controller deployment role. So we can see there is one controller and 2 compute nodes, as Jirka Tomášek deployed in one of the previous presentations. Now we are going to focus on one of the compute nodes. We can see there are some information from OpenStack APIs, but there are also information about the file system and system services, which were captured by smart state analysis, which is process of direct connection to the VM and get information from there. On this undercloud, there is OpenStack Nova service, which runs over cloud instances. The OpenStack Overcloud is a cloud provider here, and again shows basic information about the stack and the relations to various OpenStack objects, including instances, volumes, and so on. Now I'm going to show you how to create a compliance check, which will ensure that the CPU usage is not too much, so the node is not overloaded. This is a compliance policy feature which allows CloudForms to check it automatically. We have the compliance policy, so we are going to add it to one of the hosts. It will be the controller node, compute node, and these policies can be grouped in the policy groups, and we are going to add it. Now we can initiate the policy check manually and see what is the result. Everything looks okay, so the compliance passed, we can see it here. Now let's go to the last step of this presentation. Let's say we want to remove one of the compute nodes from the OpenStack undercloud deployment. We are going to choose this undercloud compute node. In order to remove it from the deployment, first we need to switch it to maintenance mode, and also we need to ensure there are no running instances. The switching to maintenance mode can take some time, but when it's finished, we can go to the OpenStack undercloud page and try to initiate the scale down action. We need to choose the right node, which we can see it's in the maintenance mode and there are no running VMs, so it's safe to remove it. When scale down action was initiated, there is some background job on the OpenStack heat service, which runs the real scale down. Again, this might take a few minutes or maybe even long, but when it's finished, we can check hosts of the undercloud, and we are able to see that the host we chose was stopped. And also in the topology view of the provider, we can see that current configuration contains only one compute and one controller node. That's all from me, and I would like to invite you to one of the OpenStack talks in room E104 or to visit the ManageIQ booth here in the hall. Thank you.
Thank you, that's Merrick Ofart. You know, the cool thing about CloudForms, it's one single pane of glass where you can see the resources for RHEV virtualization, OpenStack, and we didn't get into it here, but it also depicts containers as well. So it really helps to ease the training curve on system administrators. Okay, next up we have Josef Karaszek.
So hello, now I represent the developer here, and I have all of these dynamically provisioned hardware that I can use. So I will deploy some application on it. It will be written in Java. And I will actually deploy a whole cluster of application containers. And I want to demonstrate that these traditional Java middleware services work very well in the OpenShift environment. And the way how I will demonstrate it, I will create a cluster of my application servers, and they will all share the stateful information, which is basically information about the session. And what I will do on the go, I will run a rolling update in the environment. So this means I will kill every single instance of my cluster. And when I get to a new version of my cluster, of my application, this will be totally transparent for the client. They will see no downtime. Basically, the application still will be responsive and operational. The architecture of my application is, okay, I was going to have one more slide there, is 3 nodes. That talk to each other in a cluster, and they use PostgreSQL as a backend. So here you can see that I've started deployment of my application in OpenShift, and I also start a build of my source code. So first it goes to Git repository and downloads the code and runs the build. What I'm going to do, I'm going to add a webhook on my Git repository. So anytime I push to Git repository, a trigger is initiated, and a new build is started, which I will do in a few moments. So now we can see that the application is still building. I'm downloading all of my dependencies, all of the source code that I use. And once I have the application compiled, the application will be baked in a Docker image, and the Docker image will be sent to Docker registry, which is part of the OpenShift infrastructure. Here we can see that the layers of the image have been pushed to the registry, and now the deployment is started, which means that the image is downloaded on the nodes where the application is scheduled. And once this is done, the application will be available and accessible. So here we go. I can access my very simple web form. And this data that I input here, this is stored in the PostgreSQL. So this is very simple, just the username, first name, last name. And I'm using a browser which automatically sends the session information to the cluster. Here is also important information is the node where I landed as first. This will be useful as we go to a new version of my application. We will see that I'm talking to another node. So let's change the source code. Just add some change to the Java file, commit it, push it through Git repository, and as I said, a new build will be automatically triggered. This will pull down the updated source code and compile it again. So in the UI, we can see that the new build already started, and now it is a lot faster because it uses the artifacts, the dependencies that were downloaded in the first build. And this is the UI for what we call rolling update. We slowly go from version 1 to version 2 of our application. So you can see that the nodes on the left are slowly dying, and the nodes on the right are becoming ready. And all of the stateful information was also copied to the new server. So you can see that I didn't receive server error status, but this is HTTP 200 success. So that's all. Thank you.
Thank you, Josef Karaszek. Okay, next we're going to talk a little bit about JBoss, heavily used in the application development space. For that, we have Dmitry Bokarov. He got in a barroom fight, if you're wondering what's going on here.
Hello. I'm going to speak about the top-level corner of the diagram, and it's JBoss tools. So Red Hat JBoss Developer Studio is a certified Eclipse-based IDE for developing, testing, and deploying your applications. Developer Studio includes a wide range of technologies and tools for OpenShift, Hibernate, Java EE, and many more stuff. So let's start with installing Developer Studio. Since recently it is possible to install Developer Studio with a simple DNF install command as an RPM. And while it is installing, I want to say that I'm going to demonstrate you how to use OpenShift tools in Developer Studio. It is great that you can do lots of stuff right in your IDE without using terminal. I will show you how to connect to the OpenShift instance, how to build your application, how to manage the OpenShift, and some other stuff. Firstly, we need to open an OpenShift Explorer view. And let's create an OpenShift connection. We'll connect to the OpenShift instance, which was just showed by the previous speaker, Joseph. To do this, we just need to type in the IP address of the OpenShift instance, type in the username and the password. As soon as we've done this and click Finish, we can see that a new item appeared in OpenShift Explorer view. And we can see there his Joseph's project cluster, all the services, and the containers. This is exactly what we saw in OpenShift console view in an external browser, where we can go easily with just a right click and show in a web browser. The next thing we need is to get the source code of the application. To do this, we just click on the service and import application. We see that a new project appeared. Let's open it in a Package Explorer and go to the class that was just changed by Joseph. And we'll see that his changes are there. Next, we want to run this application, and we can do this right in the internal browser of the Developer Studio. We click on the right click on the service and show in internal web browser. And here's the application which we saw recently. Now, let's create a server adapter for the service. And we saw that changes made by Joseph were applied after git push operation. In Developer Studio, you don't need to do git push. You just need to change the file, save it, and it will be deployed by the server adapter right into the deployed pods of the OpenShift. We can see that changed file is already on OpenShift. Let's try it. And we'll see that the changes are applied. One more thing that you can do with server adapter is to debug your application. You just need to restart the server adapter in a debug mode. And then we put breakpoint and try our application once again. So now we can see that a debug mode started, and we can easily debug our application. Now I want to show you how you can manage the number of containers which your application is running on. We can just scale up our service easily to the number of pods we want, right in your IDE. For example, 5, and we can see that the number of containers increased in OpenShift Explorer, and the same we can see in OpenShift Web Console view in external browser. You also can build your application right in the OpenShift, but through the Developer Studio. To do this, you go just to the properties of the service, choose the build config, and with the right click, you start a new build. At the top of builds, you can see that a new build is running. And you can see the logs right in the console view of the Developer Studio. These are exactly the logs that you can find in OpenShift Web Console in the external browser. So I want to invite you to the Developer Tools sessions, which will be in Saturday evening and on Sunday during the whole day. You can find them in the timetable with the label DevTools. Thank you.
Thank you, Dmitry Bokarov. I think you can really see here how integrated the tool sets are, because that was right within the development GUI. It was directly going behind the scenes and creating the containers in OpenShift. So that's really the whole point, is that this should be like a seamless end-to-end experience. Last up, we're going to complete the developer experience with Nenud Peric. No? We're not? All right. So we'll wrap it up then. Okay. So was this stuff real? Hell yes, it was real, right? Are these guys real or what? So I think the whole point is that, this is all open source software. And so, we're just showing some of the cool stuff that we've been doing here at Red Hat. We welcome, I hope there's a lot of community people here in the audience who are welcome to join us and participate. Great way to learn. There's people in universities, students. It's a great way to get into the business, to try to see the source code for this stuff, to mess around with it yourself. If there's customers or business users in the audience, a lot of our customers directly add features or tailor these programs to meet their needs. And that's really the value and the power of open source. So I hope that that's been useful and that you can really get an overview of a lot of the different technologies we have, that you can learn more as the session goes on. So what we've done, just as a wrap-up, we've started from bottom to top. First thing we did was provision the hardware through satellite. Next thing we did was create virtual machines using RHEV. Then we created identities, policies, and accounts to be used cluster-wide. After that, we used OpenStack to create a pool of dynamic virtual guests. And after that, we brought in OpenShift to create a containerized application environment that we later saw in the development slides was well integrated with the Eclipse-based tools as well as the JBoss services. And also along the way, we showed using CloudForms how we can manage, set policies, scale and grow our clusters, and be able to do things like accounting and compliance checking. So it's a really full end-to-end solution. So with that, I hope this has been a good session for you. I want to invite the guys back up on the stage and thank them for a job well done, and hope you enjoyed DevConf Brno. Hold on. All right. Good job, guys. All right, thanks again.
Ha migliorato un sacco di cose dappertutto. Dai, grazie per il consiglio, sì, siamo giusti.
So just switch it.
switch it from VGA to HDMI.